Okay, so to solve systems of equations, we're really just looking for an x value and a y value that satisfies both equations. So we can find that in multiple different ways. Um, and so the three that we're going to be looking at mainly in this class are um, substitution, graphing, and elimination. So basically each one of those different types makes sense. You're either finding the expression in terms of one variable and then substituting, or you're in this case we're just going to treat them like two lines and graph both of them. With elimination, we're multiplying and adding the two together to try to get one of the variables to cancel out and can solve for the other one. Um, so we're going to look at um, graphing as a method to solve these this time. So basically we need to rearrange these into two types of lines that we can um, easily graph. So we want to get the y by itself each time because we need it in y equals mx plus b format. So let's start by copying them over and starting to solve. So we're going to get the y by itself. So the first thing we're going to do is subtract 21x off both sides. Alright, and that is going to give us, let's see, these are going to cancel out, and we'll have 7y equals negative 21x plus 42. Alright, so now we can divide everything by 7 because that is what is in front of the y. And it will give us, let's see, y equals negative 21 over 7 is negative 3x plus 42 over 7 is positive 6. So we will graph this line as the green one, and we'll get ready to do that. Meanwhile, we can make sure we solve for the other one. So we'll set one of these lines up in a minute. Let's go ahead and solve for this one. So for that, we will copy it over. Let's just do the process again. 10. All right, so in this one, we'll add to both sides because we've got a negative x value over here. So we should try to get that to the other side so we can leave this y by itself. So we'll add that to this side. We'll have 5y equals positive 5x plus 10. Okay, should be simple enough to divide out factors here to get y by itself. Let's make that 5 look a little better. Alright, so to finish up here, we'll get y. Let's pick our color of choice to match up sort of with this other colored line. So y equals, no, not really. 5 divided by 5 is just going to be 1 or just x, and then plus 10 over 5 would just be 2. So that would be the other solution. So let's go ahead and graph them. We got y equals negative 3x plus 6. So we will go to plus 6, or y-intercept, plus 6 for this line. And we have a slope of negative 3, so we'll go over 1 and down 3. We can also just think of it as, we've got a vertical component of 3, horizontal component of 1, and we know that the line needs to point off in this direction because that is our negative side. If we point a line over here, we know that it's a positive slope. We know that we need a negative slope for this, so we'll leave that pointing this way. So for the other line, we know that we start with a y-intercept of 2, and we need a positive slope of 1 over 1. Because we know that this, the absence of any number right here just means that we're talking about 1. So our slope value for this line is 1. You can be a little more accurate there. All right, so we got 1 over 1 starting at a value of 2. We got negative 3 starting at a value of 6. So we know that, we know now where to find our two values, one x value and one y value. And the x and the y value that we're talking about here are the solutions to the expression. So basically all that means is that we just need to realize that this intersection point right here is, this is just simply the intercept. So this is the point here, and it's not always going to be a bubble dot there for you. So, you know, it's just the same as if we had this. Okay, that's the same line. Don't need to have the dots there. Move them over. Right? So that's still our intersection point. It's an x value of 1. So we can put that here. And it's a y value of 3. So we can down here, put that here. Okay.